We've already looked at a couple of graphs that can help us visualize statistical information, but we can also organize and collect statistical information in charts or tables. In example 9, a fair six-sided die was rolled 34 times, and the results are recorded in the table below. We want to, in part A, calculate the relative frequencies and the cumulative relative frequencies of each result. For relative frequency, that is the number of times a particular outcome occurred divided by the total number of experiments, which in this case is n equals 34 different times that we rolled this die. So if we rolled a 1 10 times, that relative frequency would be 10 divided by 34, or approximately 0.2941. The number of times we rolled a 2 were 4 out of 34, which would be approximately 0.1176. And we continue that same process. 8 divided by 34 would give us approximately 0.2353, 0.0882, 0.1176, and 0.1471. Then in the next column, we can calculate the cumulative relative frequency, which means we want the relative frequency of that outcome and all preceding outcomes. So for our outcome of 1, that cumulative relative frequency would be 0.2941. To get the cumulative relative frequency of an outcome of 2, meaning how many times we got 1 and 2, we would take that preceding value and add the relative frequency for this outcome. So we would take 0.2941 and add 0.1176 to get 0.4117. And then to that result, we would add 0.2353. And we would continue that process to get 0.7352, 0.8528, and 0.9999. That tells us then, if we want to look at a particular outcome, say 4, the relative frequency of getting 4 or lower is 0.7352 or 73.52%. We're asked in part B to find the total of the relative frequencies that we entered above. We actually did that as we found the cumulative relative frequencies, but we could go ahead and just add all of the values in our relative frequency column, and that would add to 0.9999. Now, theoretically, this should add to 1, because if we look at all of the possible outcomes occurring, that frequency should be 100%. If we're okay with any of the outcomes, anything that occurs counts as a success, then we would have a success 100% of the times. In this case, we didn't get 1, but that's okay because this is due to rounding errors. Or not really rounding errors, but rounding. As we calculated these different relative frequencies, we would have gotten more than 4 decimal places, but as soon as we start rounding values, rounding introduces error because our results are not as precise as they could be. But whenever we come up with a chart like this, our relative frequencies should total should be approximately 1. They might come out to be exactly 1. They might just come out to be something very close to that. Again, due to those different rounding errors, but should be pretty close.